So you're going to spend a lot of time this quarter, next quarter, the quarter after that, adding and subtracting polynomials. The good news is it's just like combining like terms with just a slight tweak on the subtracting. So adding is exactly like combining like terms. And remember what like terms are. Same variable, which is the letter part, same power, exponent. Okay. Subtracting, well, you may remember from some time in your life that subtracting is the same as adding the opposite. And opposite in math lingo means different sign. So when you first started learning about arithmetic with signed numbers, and if you haven't reviewed that lately, it's in Chapter 1. So if I have, for instance, 6 minus 8, the one way that you can think about that is 6. So instead of subtracting, I can add a negative 8. So I can turn this subtraction into an addition by changing the sign of the second number. Okay. Well, when we have a polynomial, what we do is we change the sign of all of the terms in the second polynomial. Okay. So we'll get to that in just a second. So let's practice our adding first. So one of the things we'll take a look at, because the parentheses here, right, are just for effect. They really have no effect on what's going to happen. But there are places you want to look to make sure that we can just drop them. So you want to look out in front over here to see if there's a coefficient we might need to multiply. If there is, then we'll multiply it through. There's nothing here, so we're good. We'll also look up top to see if there's an exponent. Okay, there isn't. So these parentheses here are completely gratuitous. We don't need them at all. So I could write that first polynomial without any parentheses, and it would mean exactly the same thing. So 5a squared plus 12a plus 4. Now I'm going to look at the second set of parentheses. So I have a plus in front. That's good. No number, no power. So these parentheses here are also gratuitous. Just drop them. They're not changing anything. So plus 3a, oops, minus 7. Couldn't see that. Okay, so now I've rewritten it without parentheses. It's exactly like combining like terms, so just run through and combine them all that you can. So remember, I usually start over here at the left, and I just walk through, and I pick up everything that's the same. So the first thing I find are 5a squares. I'm looking for other a squares. I don't see any, so 5a squared doesn't have anybody to combine with. So I'm going to go ahead and put a mark through that so I know I've taken care of it. The next thing I come across is 12a. So now I'm going to look for other a terms. A to the first. 3a. Here it is. So 12a plus 3a is 15a. Right? The variable stays the same once they add. And now the last thing I come across, so back over here, taking care of, 4 minus 7 is negative 3. Or 4 plus negative 7, negative 3. Okay, so there we go. So if you want to go ahead and pause and try this next one first. Again, we notice nothing in front, no power up here outside the parentheses, so these parentheses can just go away. I have a plus in between them that says take this thing and add it to this thing, right? First polynomial plus second polynomial. Checking the second polynomial, no coefficient, no number up top, so these guys can just drop. So rewriting that without any parentheses, 6x minus 2x squared plus 5x cubed plus 4x cubed plus 2x squared plus x. And now we will combine like terms. So this time the first thing I find is 6x. So I'm looking for other x to the first. There's one more down here, so 6x plus x is 7x. Go ahead and go back and take care of the ones we used. Negative 2x squared, and this has an x to the third, x to the third. I can't combine, they're not the same power, right? I'm looking for a power of 2 on my x. So it's right here. So I have negative 2x squared plus 2x squared. So a positive, right? They're opposites. So those guys add away. I don't have any x squared. You can, if you need to, write a 0x squared, but we usually don't. These just add away, completely cancel. And then I have, let's see, my next thing is 5x cubed plus 4x cubed. So 5 plus 4 is 9x cubed. Okay, so this is a perfectly fine answer, but if you were asked to write it in descending order, the smiley face, better answer would be to put the 9x cubed, because that has the highest power, first, and the 7x second. Okay, so that's adding. For subtracting, it's 6x plus 1, so I look at the parentheses on the first one, nothing in front, nothing I'm raising it to, so I can just rewrite this without the parentheses. Second set, now here's where it gets interesting. I'm subtracting off everything in that second set. So this minus sign in front of it has to apply to everybody inside there. So I'm going to subtract 2x, and I'm going to subtract the 5. So when I go to rewrite that second polynomial without the parentheses, I need to change the sign of everything that was inside the parentheses. Okay, so the 2x used to be positive inside, so outside it's negative. The 5 is positive inside, outside it's negative. You might also think, and you'll hear me say and draw something like this, is that negative sign goes in and it distributes. It affects all of the terms inside. Okay, so now we have it written without parentheses. We combine like terms. 6x minus 2x is 4x, and 1 minus 5 is negative 4. Last example. Rewrite this without parentheses first. Again, change the signs of everything in the second set. So 3x squared plus 4x minus 7 minus x squared. Oh, here's a tricky one, right? So minus the x squared. Now it's minus a negative 5x. So minus a negative is plus a positive, so plus 5x. Right? The sign changes. And then minus a positive 1. Okay. So if I just looked at these three terms here, negative x squared plus 5x minus 1, all of the signs are exactly opposite from what we have inside. Okay, and then combining like terms. 3x squared minus x squared is 2x squared. 4x plus 5x is 9x. And negative 7 minus 1 is minus 8.